Hello class, we're going to look at the domain and combinations of functions, but before we do any combinations, let's determine what our domains can be. First thing we're going to do is assume that the domain is going to be all real numbers. A lot of our parent functions are all real numbers. There's only certain times, well, let me give an example of where we'd have all real numbers. So if we had f of x is equal to x squared plus 3x minus 17, that domain is all real numbers, and we'd write negative infinity to infinity because there's nothing that makes an exception. But we're going to assume that, but then we're going to look for some exceptions for our domain, and there are some. The first exception that we're going to look for is if the denominator, if they have a denominator and we have an x in the denominator, whatever that x would be that makes the denominator 0 would be an exception because we can't divide by 0. So if I have an example of g of x is equal to 5x over x squared minus 49. Well, I don't care what's in the numerator because we can have zeros in the numerator. It's just that denominator we can't have zeros. So I'm going to take that x squared minus 49 and say that cannot equal 0. Well, x squared minus 49 can be factored into x plus 7, x minus 7. Neither one of those factors can equal 0. So x cannot be positive or negative 7. That's the restriction on the domain. It's going to be all real numbers except for that. And then the other exception that we're going to look at is going to be in the radical. If we have a radical that has an even root, like 2, 4, 6, that radicand, the numbers then underneath the radical sign, cannot be a negative number. So they must be greater than or equal to, and I didn't put that part on these, greater than or equal to. So if I have a function that says the square root of 9x minus 27, I'm going to take that 9x minus 27, and I'm going to say that that has to be greater than or equal to 0. So if I add 27, my 9x has to be greater than or equal to 27. And if I divide by 9, then that gives me x is greater than or equal to 3. And that's the restriction of my domain. So we are going to take some of our functions and we're going to add, subtract, multiply, and divide. Now I'm going to ask you to state the domains of those combinations as well. So let's do, the first step in knowing those domains is we have to look at the domains of each individual function that we are combining, because that will, any exceptions are going to be the exceptions for our combination as well. And then once we've done the combination, we look at the resulting function and see if there's any additional exceptions before we would simplify anything. Oops, I forgot that. There we go. Before simplifying, and determine if there are any other things that we have to exclude from the domain. Let's look at some examples. So we're going to take two functions. The first function is f of x equals x minus 5, and the second function is x squared minus 1. Now, they both have no exceptions on their domains. So that will not play a part into finding the, what we're looking for. So when we're going to do f plus x, we're going to take what f of x is, which is x minus 5, and we're going to add it to the g of x, and the g of x is x squared minus 1. We want to simplify that as much as we can, so we're going to combine our like terms, and let's put them in the standard order, so with the highest power first. So we have x squared, and then we have an x, and a -5 and -1 added together gives us -6. This is still a quadratic as well, and so the domain has no restrictions, and it's -infinity to infinity. Using those same two, f of x and g of x, which have no restrictions on their domains, let's take the look for what it, when we subtract it, we're going to take x minus 5, and we're going to subtract x squared minus 1. Notice this time I put my functions into parentheses, and that's because I want to distribute this negative sign to every piece of that function that I'm subtracting. So I'd rewrite that as x minus 5 minus x squared. And when you subtract a -1, it's like adding a 1. So my final one is going to be -x squared plus x, and -5 plus 1 gives me -4. This once again has no restrictions on the domain, so it's going to be -infinity to infinity. Now we're going to get into multiplication. Once again, we have no restrictions on our functions, and we're going to multiply x minus 5 times g of x, which is x squared minus 1. These are two binomials, so we are going to FOIL. So x times x squared is x cubed. X times -1 is -x. -5 times x squared is -5x squared, and -5 times -1 is +5. I just want to put this into standard form where I go from the greatest degree to the lowest degree, so I'm going to have x cubed minus 5x squared minus x plus 5. And that's my answer. Oops, let's give our domain. Once again, I have no restrictions, so it's -infinity to infinity. And there we go. All right, so now we're getting into the division. This is going to be my numerator. This is going to be my denominator. So I'm going to have x minus 5 divided by x squared minus 1. Now I have a denominator. That does put a restriction on our domain because that denominator, x squared minus 1, cannot equal 0. So let's find out what values of x cannot equal 0. I'll factor this into x plus 1, x minus 1 cannot equal 0, and neither of those factors then can equal 0. That's a minus 1 cannot equal 0. So if I subtract 1 here, x cannot equal -1, and on this one if I add a 1, x cannot equal a positive 1, so x cannot equal positive or -1. Nothing simplifies. Even when I factor, I have an x plus 1, x minus 1 in the denominator. It doesn't factor with x minus 5, so I can keep this as my simplified form. So I would say, or I could put it in the factored form, and I'd have x plus 1, x minus 1, that's a 1. And then my domain, I would state that x cannot equal positive or -1. If you want to put that in set notation, it would be -infinity to -1, and then -1 to 1, and then 1 to infinity, where these ones and these -1s are your exceptions to your all real numbers, which is -infinity to infinity.